Okay, Algebra 2, this is study guide for the Unit 9 test. We're starting with number 16 here, solving some equations with E, all right? And remember, E is just a number. It's approximately 2.7-ish, and we treat it just like we would any other number raised to an exponent. So e to the x plus 2 minus 5, actually let me do b, so I have more space on my paper. So e to the x minus 3 plus 4 equals 43.7. So I need to isolate the exponent term, the e to the x minus 3. So the first thing I need to do is subtract this 4. So that gives me e to the x minus 3 equals 39.7. I just subtract 4 from here. Once my exponent term is isolated, how do I get rid of an exponent, of a base raised to an exponent, and the variable is in the exponent? I have to undo this base. So the opposite of an exponent is a log. So I need to take the log using whatever base will undo e. So log base e is the same thing as ln. So I'm going to do the ln, the natural log base e of both sides. Doing the log ln of e cancels them out, and I just get x minus 3. And then ln of 39.7, we just type in the calculator. So I'm going to do, then there, for ln, you just use the ln button right here. So ln of 39.7 is 3.681, blah, 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 blah. I'm just going to put 3.68 on my calculator. But I'm going to leave the answer sitting on the screen. And then when I do my last step of adding 3 here, x equals 6.68. Okay. Or if you typed it in the calculator, this is nice if you're like multiplying or dividing and it's not easy to just add the front digits. If you keep the same number with all the decimal places on your screen, you're going to get a more accurate answer at the end. All right, so let's move on to number 17. Here we are solving an ln equation. So to solve for x, round to the nearest hundredth again. So just like in the last problem, we wanted to get the exponent term by itself. I need to get this ln term, the ln of 4x plus 1, by itself. So I have to start by subtracting 2 from both sides. So then I get 3 times the ln of 4x plus 1 equals 9. And now I need to get rid of the 3. So I would divide by the 3. All right, so now I have the ln of 4x plus 1 equals 3. Let's see, my paper's a little bent here, sorry. So the ln of 4x plus 1, sorry for that out of focus, equals 3. So now I need to get rid of the ln. So 2 ways to think of this, right? We need to rewrite it into exponent form. The base of ln is e, right? ln is log base e. So if I'm writing this in exponent form, I'm going to say the base, which is e, to this exponent, the third, equals this result, 4x plus 1. E to the third, I just put in the calculator. E, remember, is on top of your ln. So you do second ln to get to the e to the x. And so e to the third then is 20.09, I'll write down. 20.09 equals 4x plus 1, and then I just solve for x. So I'm going to subtract 1. So this 20 point whatever minus 1, and then I'm going to need to divide by 4. So divided by 4 is 4.77. And again, I could go back, show that I subtracted 1. I've still got those answers sitting on my screen. 19.09 equals 4x. When we divided by 4, we got x equals 4.77. All right, so I'm going to go ahead and look at number 18 on this video as well, and then we'll have one last video for the final few problems. Okay, so looking at number 18 here. All right, solve for x, and I have 2 logs log of 5x plus log of 2 equals 2. So I have to combine these two logs into one before I can solve, because I have to isolate a single log. So because they are adding, I'll combine them with multiplication. So 5x times 2 is 10x. So the log of 10x equals 2. And so then log of 10x equals 2. I need to combine those. I need to rewrite that in exponent form. So what is the base when no base is written? It's 10. So log base 10 of 10x equals 2. Write it in exponent form. So the base 10 to this exponent 2 equals this result 10x. So 100 equals 10x. Divide by 10 and x equals 10. This actually came out with very similar to a problem we did earlier, but it's just a little bit different. All right. So you'll find the answers for 19, 20, and 21 in the last